students, I'm your Komali Mam. In this session, I'm going to teach you all excellent tricks to find optical isomers. This is one of the topic where students feel difficulty in finding this optically active forms, optically inactive forms, enantiomers, meso compounds, how to find which formula I have to apply. That kind of confusion will be there. So in this session, I am going to teach you this. By the end of this session, you will find for these questions and you will solve fatafat within just a second. So you will be able to solve the questions. And I am taking online classes too. If you are the one you want to learn, full chemistry syllabus from basics to the depth, then you can join my online classes. Classes are like very interactive. You never feel like an online only. And syllabus you will learn, from basics onwards you will learn. And your class teacher may say, your chemistry teacher may tell you, no, you don't have that much of brain, you are not studying well, or you are an average or below average student, or you're a topper, or your parents need more marks from you in chemistry, then these online classes work out very well for you, and you no need to worry like I'm a little slow learner. Will I able to understand through online? You will understand. Your chemistry is my responsibility. If you are in my class, I will guide you step by step. One question, I'll guide you. Next question. Each and every concept I'll teach you in a clear manner. I'll give you my number here, and in description, just you can WhatsApp me for more details. Let us see how can you find the optical isomers. Okay, optical isomers formula is optical isomers. See, optical isomers, how to find? See students, first you have to find the stereogenic center. I'll tell you what is the stereogenic center. I'll tell you. You just see the molecule is having dissimilar ends or similar ends. This also will guide you. What is this similar ends or dissimilar ends? What is the formula? Dissimilar ends and similar ends. Okay. After that, if it is a dissimilar end, then the formula you have to use is 2 to the power of n. What is dissimilar end? You just cut the molecule and you see left to right or right to left. It should have similar nature. I mean similar connectivity. We will see the examples. And ma'am, no ma'am, it is not dissimilar. Similar ends. Then you have to use the formula in a 2 different manners. If it is a similar ends. What is that? If n is even number, then one way you should solve the questions. N is odd number. You have to solve questions in another way. Ma'am, what is this n only? N is nothing but it is a stereogenic center. What is n, students? Stereogenic center. What do you mean by this stereogenic center? Asymmetric center. What do you mean by this asymmetric center? Chiral center. What is this chiral center? Carbon which is surrounded by 4 different groups. What is that? Carbon which is surrounded by 4 different groups. A, B, C, D. That carbon we call it as which carbon? Chiral carbon or asymmetric carbon or stereogenic center in optical isomers. Okay. If it is a dissimilar case, directly how many such kind of chiral carbons are there? Substitute in this formula 2 to the power of n and find it out. No ma'am, it is a similar ends. Then n is even na, odd na, you just check it out. If n is an even number, then the formula to find the total optical isomers. Total optical isomers. See, the meaning of total optical isomers is both optically active plus optically inactive. Is it clear? Both optically active and optically inactive. Formula is 2 to the power of n minus 1 plus 2 to the power of n minus 2 by 2. See the formula? 2 to the power of n minus 1 plus 2 to the power of n minus 2 by 2. Okay? This I can write like this also. 2 to the power of n minus 1 plus 2 to the power of this one simplification I am doing. N by 2 minus 2 by 2 is 1. So either you can see this formula while solving or you can use this formula while solving. Ma'am, what is this? In this, one technique shall I tell you? Super technique. This is there now, 2 to the power of n minus 1. This formula gives us optically active forms. This 2 to the power of this formula is there, right? Which one? 2 to the power of n by 2 minus 1. This part is there, na? This part will gives us, means this part gives us optically inactive forms. Optically active forms are also known as enantiomers. Optically inactive compounds are known as meso compounds. Meso compounds. Okay, ma'am, I understand. If they ask meso compounds, I use this formula. If they ask optically active or enantiomers, I have to use this formula. If they ask optical isomers, I have to use 2 to the power of n minus 1 plus 2 to the power of n minus 2 by 2. That's it. Let us see if n is a odd, how to use. Next page I'll go. Here I'll write if n is odd number like 3, 5, you get number of stereogenic center, then the formula to use optical isomers. Optical isomers. Which optical isomers, students? Total optical isomers. Which means both optically active plus optically inactive. Formula is just 2 to the power of n minus 1. Huh? What is the formula? 2 to the power of n minus 1. That's it. If you want to find optically inactive forms, then the formula is optically inactive. Inactive. What is the formula? 2 to the power of n minus 2. 2 to the power of n minus 2 by 2 is before case. Okay. Here 2 to the power of n minus 1 by 2. See what is the difference? In an even case 2 to the power of n minus 2 by 2. In odd case 2 to the power of n minus 1 by 2. That's it. That is only the difference. And coming to this is optically inactive formula. This is total isomers. If from total isomers, if you subtract optically inactive, you get optically active. See, from total is equal to optically active plus optically inactive. Total formula is what? 2 to the power of n minus 1. Optically inactive formula is what? 2 to the power of n minus 1 by 2. You want optically active formula. How to find, students? Tell me. Optical active isomers formula is 2 to the power of n minus 1 minus, if it goes that side, you get minus. Okay, minus 2 to the power of n minus 1 by 2. In this, what I am telling you, this gives optical total isomers, total optical isomers, total, this is total. This is inactive forms, inactive, optically inactive. Optically inactive also known as meso compounds. Optically active also known as enantiomers. Okay, that's it. Note it down these formulas. Very easy. Just to copy these formulas, you see how easily you will be able to solve. First question. What do you mean by stereogenic center? How to find the stereogenic center? Carbon which is surrounded by 4 different groups, we call it as stereogenic center. Okay, see here, this carbon is You no need to worry. Chemistry is like very easy and interesting subject. You no need to like have a fear about that. Every question very easily you can solve. So many tricks and tips are there for each and every concept. You can apply because in a NEET examination, or you can say JEE examination, you have to solve the questions within the time period. If you apply full methods and you solve, if it takes long procedure for 2 to 3 questions, if you take 10 minutes of time, then how can you able to solve the entire question paper? So first you should understand the concept, then you should apply the logics and tricks, and short way you should solve the question. See, this is surrounded by 4 different groups. Carbon is surrounded by 4 different groups. So stereogenic center is 1. And this is similar ends or dissimilar ends. You see here, if I cut here, left side CH3 is there, right side C2, CH2, CH3, different groups. Dissimilar ends. Dissimilar ends, what is the formula? Tell me formula loudly. N is equal to 1. Sorry, 2 to the power of n. So here n is equal to 1. Then 2 are possible. So this CH, it can be, 2 are possible. One is R or one is S. Anything. One R, one S are possible to that. What is R, what is S? Later we see. This is how many optical isomers you have to find it out. That is the concept. Okay. See the next question. How many chiral center? This is a carbon which is surrounded by 1, 2, 3 groups, and carbon is surrounded by only 4 bonds. Means one is hidden hydrogen. Total 4 bonds. Okay. Tell me students, everything is different. Dissimilar ends. 2 to the power of n is the formula. Then 2 to the power of n value is 1 here. Then 2 to the power of 1 is 2. So optical isomers are how many? 2 to the power of 1. 2 isomers are possible. See the next question. How can you find the total number of isomers? Okay. First find total number of isomers. First find the stereogenic center. This center is surrounded by 1, 2, 3. This entire group, 4 different groups. This is one stereogenic center. This is one stereogenic center. Okay. See the next one. See the next one. This is surrounded by this carbon 1, 2, this entire group 3 and 4. So this is one stereogenic center. So total how many stereogenic centers are there? 2 stereogenic center. And now tell me, this is having similar ends or dissimilar ends. How can you find it out? Cut this molecule like this. Just check it out. Your left hand side, down side CH3 is there. Top side CH3 is there. See, similar ends and dissimilar ends means you should not check only first carbon, last carbon. Okay, everything you should check and go. For top CH3 is there, down also CH3 is there. Then here HOH, here HBr. Clear students? See, this is a dissimilar end. Down is different part, top is different part. Dissimilar ends. Then dissimilar ends. Here dissimilar ends. N is equal to 2. Dissimilar ends, what is the formula students? Tell me. Dissimilar ends. Dissimilar ends formula is 2 to the power of n, where n is equal to 2. So 2 to the power of 2 is equal to 4. So number of optical isomers are 4. Optical isomers are 4. See the next question students. Question number 4. Wait, I will do. Question number 5 you do. CH3. See the molecule. Try, come on. Will you try? Try this question. Question number 5. And question number 6. Just to try this question. Even na, odd na. Similar ends na, dissimilar ends na. Total 3 questions. Try question number 6. And question number 5, take a screenshot. Okay. Question number 3 is very important model. I'll explain now. See, question number 3, very important model. Because of this only students feel difficulty. Just observe this question. Students, here. How many stereogenic centers are present? See, this is surrounded by one group, 2, 3, this side entire group. Okay, one stereogenic center, total 4 groups. And see here, this is surrounded by, this carbon is surrounded by 1, 2, this entire one group. Okay, then this hydrogen is one group. Fine. Okay, ma'am. 2 stereogenic center. Then how many middle carbon? If you see middle carbon, this side group and this side group are similar. Left side group and right side groups are similar. What we are discussing, asymmetric carbon means carbon which is surrounded by 4 different groups. But in this case, this side similar is there. So how can it will be asymmetric carbon? It is not asymmetric carbon. So we will count it as a similar ends question. What to say? Even n value, stereogenic centers are 2 and we will solve the question. Then your answer is wrong answer. This is very, very special case where if 3 OHs are present like this, okay, 3 OHs are present like this. Check it out one time. What happens in this case? CH3, CH, OH, CH, I'll write this structure in a standing position, okay, for better understanding. CH3, H, OH, only for your understanding, I'm making, in this position and I'm explaining you, just once check it out. This carbon, this is one carbon, this one carbon. This is asymmetric carbon, fine. This is asymmetric carbon, fine. But this carbon, down group and top group are similar. Then how it will be asymmetric carbon? That is the question. See here. This also we should consider in when 3 similar functional groups are there like this. This carbon also we have to count it as asymmetric carbon. Why? Because if you find it out, this is senior group 1. Next senior group is this 2. Next senior group is 3. Next this is 4. See your I direction 1, 2, 3. R. Clockwise R. Least priority is there on vertical. So R changes to S. Next. Here I am not teaching you how I am doing R and S configuration. Already uploaded a video on R and S configuration. Next. See here senior. This entire senior, next is 3, next is 4, anti-clockwise, so it is S, but least priority on vertical line, so it horizontal line, so S converts to R. Ma'am, what you are doing? See, I found this carbon configuration, this chiral center configuration is S, this chiral center configuration is R. So whenever this configuration is different, this group acts as a different group, this group acts as a different group. Even though these two are similar groups, you should consider that middle carbon as asymmetric carbon. Ma'am, when I should solve this, ma'am, I can't do this much. Are you thinking? No need to do anything. If suppose everything is same, from left to right, right to left, everything is same, 3 similar OHs, BRs like that it is present, 3. Okay, in such cases you consider the middle carbon also chiral center. So total chiral centers are 3. Similar ends with 3 means what is the formula, students tell me? Then formula is 2 to the power of n minus 1. That's it. What is the formula, my dear students? Dissimilar ends, n is a odd number. Then our formula is 2 to the power of n minus 1. Then 2 to the power of 3 minus 1 is equal to 2 to the power of 2 is equal to 4. If they ask, this is what optical isomers. See in the question, I'm modifying the question into, let us draw the total optical isomers. Okay, optical isomers, because this is the concept of optical isomers. So the question is optical isomers, because stereoisomers is the sum of geometrical isomers plus optical isomers. Here anyhow geometrical isomers are not there, like double bond and all. And so now our part is, I'm not going to discuss geometrical isomerism now. What I'm teaching you, optical isomers. So here both are same, but let's change the question into optical isomers to avoid the confusion. Here I should give you, let us draw the total optical isomers. Fine. Previous also, wherever it comes, optical isomers question. Okay. This is 4. If they ask us to find the optically active, or let us see mesos, for example, if they are asking, what is the formula, students, tell me? 2 to the power of n minus 1 by 2, then 2 to the power of 3 minus 1 by 2, that is 2 to the power of 2 by 2, which is equal to 2 to the power of 1 is equal to 2. Is it clear? If they ask about optically active, this is enantiomers. Optically inactive, that is meso compounds. Anything they may ask you, then the formula is total minus optically inactive gives optically active forms. That is how much? 4 minus 2 is equal to 2. But in the question they are asking only optical isomers, you know, that is, then our answer is only 2 to the power of n minus 1, 4 is the answer. Okay. Next 2 questions. Try out how many isomers are possible. See, cut this side similar, this side similar. Okay, similar ends. Similar ends, n is 2, because 2 stereogenic centers are there. Substitute and tell me. See here, cut half, top to bottom, bottom to top. Like this, if you cut it will be very easy. So how many stereogenic centers? 1, 2, 3, 4. N is equal to 4. Before n is equal to 3. Okay. Try this too. In the next session, I'll give you the answers. Check it out your answers. My name is Komali. I'm your chemistry mentor. Thank you so much for watching this video. And I have uploaded many best videos in our channel Komali Mam. Just to go through that, and for learning the full syllabus, you can attend online classes which I'm taking. Thank you so much. Bye, all of you. See you again in next video.